Let me present the report on topic, the concept of developing the structure of a highly functional bionic hand prosthesis based on IoT technologies. An urgent task today in the field of medical apparatus construction and rehabilitation engineering, both in Ukraine and throughout the world, is the development of highly functional upper limbs prosthesis. Figure 1, I'm sorry. Figure 1 shows the main directions of designing highly functional bionic prosthesis, and our team is working in all these directions. With regard to the concept of development, the structures of upper limb prosthesis available on the market, it is based on a structure that has already become classic and is based on the use of so-called shell models of the fingers phalanx as well as the palm. Such models are hollow, inside which additional drive elements are placed, which greatly complicates the prosthesis design and makes it less reliable. Such a design may be seen from this picture. On this picture, according to the similar principle, the design of the most common today's bionic prostheses were developed, and some of them are shown in this slide. In terms of information, a feature of the first two groups of prostheses that are bionic and Michelangelo's hand is support for MyoPlus pattern recognition thanks to the digital interface implemented by a Bluetooth adapter. And a kind of innovative approach in the concept of iLimb prosthesis is the use of special software in the form of a mobile application. After installing which on the user's smartphone, it becomes possible to adapt the functions and adjust the operation of the prosthesis by the user himself. As per bionic prosthesis is a development of Ukrainian researchers and differs from the structures analyzed above in a number of innovative solutions. In particular, it is a modular design that allows you to quickly replace individual elements such as fingers. Also important is the approach of a kind of intellectualization, the prosthesis functions itself. The spare bionic prosthesis includes 24 sensors that register residual muscle activity on the basis of which a brain-computer interface is implemented. Also, the prosthesis training and control software uses cloud technologies and machine learning algorithms to personalize the control of the prosthesis. A significant disadvantage of the considered designs is the use of shell models of the fingers phalanx and the palm. In such a design, except the expert bionic design, it is difficult or almost impossible to make the fingers removable. Another disadvantage is the inefficient use of the finger's phalanx volume, inside which sensors could be placed to realize the possibility of providing tactile sensations. Currently, our team is researching the possibility of solving such problems, and in contrast to the traditional prosthesis designs, the design of the mobile skeleton, or in other words, exoskeleton, is being developed on the surface of which elastomeric nozzles are placed. In this case, the number of moving elements of each individual finger and the prosthesis as well is significantly reduced, and it is also possible to replace each finger when it is damaged. The use of silicone nozzles or elastomeric nozzles will make it possible to place various types of sensors in them. So if a piezoelectric, for example, piezoelectric transducer is placed in the distal part of such a nozzle, the prosthesis will be able to feel objects by touch. At the same time, the authors suggest using a group of actuators which will be placed either in a stump receiving sleeve. The actuators will be in contact with the surface of the patient's skin to make it possible to feel an object. A schematic representation of the proposed bionic prosthesis design is shown in this figure. And important for the practical implementation of all the above-mentioned elements is the solution to the task of organizing a single information system for the organization of selection, accumulation, processing, and formation of all signals necessary for the full functioning of the processes. For this, it was decided to use approaches which are practically implemented in the bionic prosthesis analyzed above, in particular bionic, babyonic, Michelangelo's hand, and Eileen. The concept of organizing such an information system can have the following options. Taking Taking into account the advantages and prospects of using IoT technologies, it is proposed to select and process both signals from tactile sensors and from AMD electromyographic sensors with the help of specialized software, which will be installed either on a computer or on a smartphone. The exchange of signals between the prosthesis and the computer or smartphone will be carried out over a wireless network. In addition, cloud technologies will be used to accumulate, store, and process data. A variant of the functional diagram of the proposed bionic prosthesis design with the main elements of information support is shown in this picture. However, the disadvantage of such a design is the need for constant joint operation of the prosthesis AMG transducers, actuators, and computer or smartphone. If the latter is turned off, the prosthesis will cease to function. To eliminate this shortcoming, it is proposed to use a concept that involves the use of a computer or smartphone at the stage of signal processing during learning to control the prosthesis and accumulating data. There are actually two stages of using the prosthesis. It's a proposed structure of prosthesis. At the first stage, a set of electromyographic signals is registered, transferred to a computer or smartphone, processed using elements of artificial intelligence and the formation of appropriate control signals for the elements of the prosthesis during the individual movements. The received control signals are entered into the memory of the processor module, which is placed in the structure of the prosthesis. At the next main stage, continuous selection of electromyographic signals and selection of appropriate control signals based on their characteristics from a set of those recorded in the memory of the processor model at the previous stage is carried out. At the same time, at the main stage, the computer or smartphone will be used as an auxiliary tool for correction errors in the operation of the prosthesis and generating new control signals for the prosthesis for its continuous self-learning and expansion of functional capabilities. A variant of the implementation of such a concept is displayed in this slide. So in this way, the proposed concept of the bionic prosthesis design development takes into account the provides of the solution of the shown in figure 1 tasks and opens up prospects for the creation of a highly functional bionic prosthesis, which would have advantages over analogs. The use of IoT and cloud technologies opens the way to prosthesis self-learning to perform new movements due to the use of artificial intelligence during data processing. Thank you for your attention.